A rectangular PSC beam is 100 by 250 mm, simply supported over a span of 8 meters. Stressing force is 250 kilonewton at uniform eccentricity of 40 mm. To stop. Superimposed load is 1.2 kilonewton per meter. Calculate stress at midspan, and second, stressing force which can be balanced stress due to dead load plus live load at bottom fiber of mid section. So first of all, draw the section of this beam. So this one is rectangular section. Yeah, so rectangular section. Its width it is 250 mm. 250 mm. Sorry, width it is 100 mm. 100 mm. And depth it is 250 mm. Depth it is 250 mm. Okay, 250 mm. So this one it is 100 mm. 100 mm. Okay. So just draw the neutral axis of this beam. It is at the center of this beam. Okay. Then next one it is so eccentricity. So this one it is position of cable wires. So eccentricity is acted. How much? This one it is given. E is equal to so this distance it is given. E is equal to 40 mm. So this one it is uniform eccentricity. E is equal to 40 mm. Okay. Then given data just write down. P is equal to it is given 250 kilonewton. 250 kilonewton. Convert it is in Newton. 250 into 10 raised to the power 3. It is in Newton. Okay. The next one it is given eccentricity. E is equal to it is 40 mm. So this one it is uniform eccentricity. Uniform eccentricity. The section of the beam it is given 100 into 250 mm. 100 into 250. So it will get section of this beam. So 100 into 250. So it will get 25 into 10 raised to the power 3. 25 into 10 raised to the power 3 mm square. Mm square. Mm square. This one it is section of beam. Cross section of beam. Okay. Then next one, calculate moment of inertia. So moment of inertia for rectangular section. I is equal to it will be VD cube by 12. Okay. So B is width into D is depth. VD cube divided by 12. VD cube divided by 12. So B it will be right on. B it will be width it will be given 100 mm. 100 mm. And depth it is 250 mm. 100 into 250. 100 into 250 cube divided by 12. 100 into 250 cube divided by 12. This one it is moment of inertia. Okay. So it will get I is equal to right now. I is equal to 100 into 250 cube 3 divided by 12. It will get 130.208. 130.208 into 10 raised to the power 6 mm raised to 4. Mm raised to 4. So this one it is moment of inertia. Okay. So now y is equal to center of gravity. Y is equal to it will be d by 2. D by 2. D divided by 2. So d it will be depth it will be 250 mm. 250 by 2. 50 divided by 2. 50 divided by 2. 50 divided by 2. It will be again how much? 250 divided by 2. So it will be 125 mm. 125 mm. So now section modulus Z is equal to it will be I by 1. I by 1. I divided by y. I divided by y. I divided by y. Section modulus it is I by y. So I it will be, we are calculated, I it will be 130 into 130.208 into 10 raised to the power 6 divided by divided by divided by y it will be 125 mm. Otherwise, you can calculate z is equal to bd square by 6 also. Okay, 130.208 into 10 raised to the power 6 divided by 125. So it will be 1.01 1.0416 into 10 raised to the power 6 10 raised to the power 6 mm cube. mm cube. This one it is section mass. Okay. So now calculate self weight of B. Self weight of B. So now calculate self weight of B. Self weight of B. Self weight of B. Self weight of B, it will be cross sectional area of beam into density of concrete. Okay. Density of concrete. Okay. So cross sectional area of beam, it will be how much? Here it will be 25 into 10 raised to the power 3. It will be mm square. Convert it is in meter square. It's 10 raised to the power minus 6 into 25. The unit weight of concrete it is 25. So it will get self weight of beam. Self weight of beam is equal to self weight of beam is equal to, just calculate. So cross sectional area it is 25 into 10 raised to power 3. It will be in mm square. Converted it is in meter square. Means multiply by 10 raised to minus 6 into 25. So it will be 0.625 kilonewton per meter. Okay. Then total load. So superimposed load it is given 1.2 kilonewton per meter. So superimposed load it is given 1.2 kilonewton per meter. 1.2 kilonewton per meter. Then total load on beam. Right now, total load on beam. Total load on beam is equal to self weight it is 0.625 plus 1 point plus 1 point. So it will be total load on beam, it will be 0.625 plus 1.2 plus 1.2. So it will be 1.825 kilonewton per meter. So just show this one, it is show here. See, total load on beam. This one it is simply supported beam. Supported beam. So UDL load it is acted on that beam. UDL load. UDL load. That's load it is 1.825 kilonewton per meter. So span of beam it is given 8 meter. In this example it is given span of beam it is 8 meter. 8 meter. Okay. So now calculate bending moment at center. So here is this part. Bending moment at center. We will write here BM at center. BM at center is equal to, when UDL load it at there, when beam it is simply supported. So W into L square by 8. So bending moment at center it will be WL square divided by 8. WL square divided by 8. 8. WL square divided by 8. WL square divided by 8. So it will get bending moment is equal to bending moment due to total load is equal to W. It will be how much? So just put here value, all this value. So W it will be 1.825 into 8 square, 8 square, 8 square divided by 8, divided by 8, divided by 8, divided by 8. From this relation, it will be 1.825 into 8 square, 8 square divided by 8. So it will be 14.6, 14.6 kilonewton meter, 14.6 kilonewton meter. This one it is total bending moment. MT is equal to 14.6 kilonewton meter. Now calculate. So I will write here. Calculate. Stresses at stresses at midspan. First question. Stresses at midspan. Stresses at midspan. So sigma T is equal to sigma T is equal to sigma T is equal to stresses at top. So first due to pre-stressing force plus self-weight, total load, you can say. So it will be P by A, P divided by cross-sectional area of beam A, cross-sectional area of beam A, then minus P by Z, minus PE by Z, minus PE by Z, PE by Z, PE by Z, plus total movement, it will be MT divided by Z, MT divided by Z. Okay. So first P by A minus P by Z, it is due to pre-stressing force. So direct stress it will be positive. Bending stress due to pre-stressing force. At top it is tension, that's why it will be minus. Due to self-weight, at the top it is compression, that's why it will be plus. Okay. So just put all this value here. So P it will be pre-stressing force, it is given in example. Pre-stressing force it is 250 kilonewton. Convert it in kilonewton to Newton. 250 into 10 raised to the power 3. It is in kilonewton to Newton divided by cross-sectional area. It will be 25 into 10 raised to the power 3. 25 into 10 raised to the power 3. Then minus PE, the stressing force again, 250 into 10 raised to the power 3 into eccentricity, it is 48 divided by Z, it is section modulus where calculated. This one it is 1.0416 into 10 raised to the power 6, 10 raised to the power 6. Then plus total load it will be bending moment due to total load where calculated 14.6. It is in kilonewton meter. Convert it is in Newton M, means multiply by 10 raised to 6. It will get Newton M divided by section modulus again 1.416 into 10 raised to the power 6. 10 raised to the power 6. Okay. It will be total stress sigma T is equal to sigma T is equal to sigma T is equal to sigma T is equal to. So first it is 250 into 10 raised to the power 3 divided by 25 into 10 raised to the power 3. First it will get 10, then minus 250 into 10 raised to the power 3 into 40 divided by 1.0416 into 10 raised to the power 6. Second term it will get 9.6, then plus third term it will be 14.6 into 10 raised to the power 6 divided by section modulus is 1.0416 into 10 raised to the power 6. So it will be 14.016. So total stress is equal to sigma T is equal to, you can write down stresses at top, sigma T is equal to it will be get 10 minus 9.6 plus 14.016. So it will be 14.416. 14.416 Newton per mm square. Newton per mm square or MP. Newton per mm square or MP. So this one it is stress at top. Okay. Newton per mm square or MP. So now calculate stress at bottom. So, right. Calculate stress at bottom. Sigma B is equal to, write down formula. Sigma stress at bottom. Sigma B is equal to so direct stress pre-stressing force due to first P by A. So due to pre-stressing force, so it is hogging type bends. So at the bottom it is compression. So that's why it will be plus P by Z. So due to external loading, so at the bottom it will be tension. So it will be minus. So due to total load, it will be empty by Z. So again put all this value here. So same P it will be 250 into 10 raised to the power 3. 10 raised to the power 3 divided by area, it will be 25 into 10 raised to the power 3. 25 into 10 raised to the power 3. Then plus P by Z again 250 into 10 raised to the power 3. It will be 40. It will be 40 divided by Z. Section modulus it will be 1.0416 into 10 raised to the power 6. 10 raised to the power 6. Then empty by Z, right? Minus empty, it will be 14.6 into 10 raised to the power 6 divided by section modulus it will be again section modulus it will be 1.0416 into 10 raised to the power 6. Sigma B it will be again is equal to, so P by A first it will be 10, then plus 9.6, 9 plus 9.6, then minus 14.016. From this relation, it will get bending stress at bottom. So sigma B is equal to right now. Sigma B is equal to bending stress at bottom is equal to, we'll write bending stress at bottom is equal to 10 plus 9.6 minus 14.016. So it will be 5.5. 5.58 Newton per mm square. Newton per mm square or MPa, megapascal. Newton per mm square. So this unit is sigma B. Bending stress at bottom. Okay. So now draw the stress diagram. Resultant stress diagram. That is cross section of B. So this position of tendon. So this neutral axis of this beam. So draw stress diagram due to, so sigma top it will be 14.041 and sigma bottom it is 5.58. So this it is resultant stress. Stress diagram. So sigma top 14.416 MPa. You can say it is also MPa. MPa is equal to 1 MPa is equal to 1 Newton per second. It will be 5.58 MPa. Okay, this is stress diagram. Okay, so now second question. Find pre-stressing force when sigma bottom it will be 0. Question. Find pre-stressing force. Find pre-stressing force when sigma bottom it will be 0. When sigma bottom is equal to 0. Sigma B is equal to 0. Sigma B is equal to 0. Sigma B it will be 0. So sigma B is equal to, formula we know that sigma B is equal to, it will be sigma B is equal to, it will be at the bottom due to pre-stressing force it will be hugging type of bend. Direct stress P by A. Direct stress it will be P by A. Direct stress it will be P by A. P by A. Then due to pre-stressing at the bottom it will be compression. So it will be plus PE by Z plus PE by Z plus PE by Z PE by Z PE by Z, then minus MT by Z due to self weight, due to external load plus self weight will be at the bottom it will be sagging type of bend. So sagging type of bend for bottom it will be tension. That's why it will be minus. Okay. So is equal to, it will be 0. Is equal to 0. Sigma B it will be 0. So just put all this value here. So we'll write here. So right here P by A, P it will be pre-stressing force 250 into 10 raised to the power. So P we need to calculate, sorry. P we need to calculate P divided by 8 will be so P it will be P into 10 to the power 3 P into 10 to the power 3 divided by cross sectional area it will be 25 into 10 to the power 3 25 into 10 to the power 3 then plus PE into Z P into E it will be 40 E it will be 40 eccentricity it is given 40 mm divided by Z it will be 1.0416 into 10 to the power 6 10 to the power 6 then next one it will be then we'll write bottom minus mt by Z. So mt it will be 14.6 into 10 to the power 6 divided by Z it will be 1.0416 into 10 to the power 6 10 to the power 6 is equal to 0 So here only unknown it is P value. Okay. Here it is also P actually you can write down P into 10 to the power 3 into 14. Okay. So write down P it will be 10 to the power 3 divided by 25 into 10 to the power 3. It will be 0.04 P. 0.04 P. So actually this one it is 10 to the power 3. 10 to the power 3. 0.043. Then plus 10 to the power 3 into 40 divided by 10 to the power 3 10 to the power 3 into 40 divided by 1.0416 into 10 to the power 6. So it will be 0.03840 T is equal to, take this one, it is the right side, 14.6 into 10 to the power 6 divided by 1.0416 into 10 to the power 6. It will be 14.0168. 14.0168. So just do the addition. 0.04 plus 0.03840. So it will be 0.0784 P is equal to 14.0168. From this relation, it will be pre-stressing force P is equal to 0.0784 14.0168 divided by 0.0784. So it will be 178.78. 178.78. 178.78. Just I will cross check this value. 178.78. Yes, 178.78 kilonewton. This one it is pre-stressing force. Okay, this is your final answer. So question 1 was stresses at midspan. So at top stresses it is 14.416 MPa, at bottom it is 5.58 MPa. And pre-stressing force which can be balanced stress due to dead load plus live load at bottom fiber of mid section. So by sigma B it will be 0. So calculate the pre-stressing force. At that time pre-stressing force it is 178.78 kilometer. Okay, this is your final answer.